today's concept is a full wave rectifier. Yesterday we have discussed about half wave rectifier. Half wave rectifier we have discussed about that. So during the half wave rectifier here, only the positive half cycle is converted in the form of DC. This is the negative half cycle, don't forget. This is negative half cycle. This negative half cycle, it has been clipped off. The negative half cycle, it has been clipped. It has been clipped in the sense, it has been cut down. So it has been removed here. The negative half cycle, it has been removed here. But this negative half cycle is also converted in the form of positive half cycle. I can say it is a full wave rectifier. It is called by the name the full wave rectifier. Okay, yes. What is that concept of full wave rectification? Okay, full wave rectifier. The whole full wave of AC is converted in the form of DC. It is a full wave rectifier. How it is said to be happening? First, this question usually we are asking for 5 marks, not for 3 marks. Half wave rectifier, most of the occasions we will ask for 3 marks question. But full wave rectifier, we will not ask for 3 marks question. We will ask for 5 marks question. Okay. Explain the action of the full wave rectifier. Action of the full wave rectifier. The working of the full wave rectifier. This is a question we are going to frame. Explain the working of full wave rectifier. Easy, very easy concepts. Maybe another 2 or 3 days I will going to cover this electronics portion. It will be finished. Okay, easy concepts, easy to understand and easy to score the marks also. From this electronics portion, most probably you will get around about 10, 12 marks. 12 marks you will get. Okay, yes, for your final exam. Full wave rectifier, what is that first idea? In the case of your transformers, if I'm choosing the transformers especially, there are so many types of transformers are there. Step up transformer, step down transformer, like that. If I'm choosing step down transformer, means the voltage we are going to reduce it. The voltage we are supposed to reduce from higher voltage to lower voltage. That is a high voltage to low voltage we are converting here. That is a step down transformer. Under the step down transformer, we are having an ordinary transformer. That is only we are having a particular voltage output only. Only one particular output only it is coming out. 2 volts, 4 volts, 5 volts, 10 volts, like that. Second one is called by the name central tapping transformer. Central tapping transformer. Central tapping transformer means this is the primary coil. This is secondary coil. For the secondary coil, at the center of this coil here, we are taking one particular output here. Means 2 wires are here. Out of that, maybe 5,000 turns are there. 2,500 turns we are putting a copper wire and we are taking outside. Remaining 2,500 windings are present. Now, number of turns. Here turns are present, number of turns of the copper wire. After about half of the number of turns, we are connecting a copper wire and we are taking output. This is called by the name central tapping transformer. In your practicals, when you are doing the experiment, okay, I told you to understand about this concept because practicals also we are supposed to have these ideas. I will show it, I said. I have promised I will show it. Okay. Yes. This is a central tapping transformer. If you are connecting between here to here, if you are connecting from this point to this point here, maybe it is going to show 10 volts. If you are connecting between here to here, it will show 5 volts. Here to here, if you are connecting a voltmeter, it will show 5 volts. Here to here, 5 volts. Here to here, 5 volts. But here to here, if you are connecting, you are going to have 10 volts. From this point to this point, 10 volts. If it is a 10 volt central tapping transformer, if you are connecting here 5 volts, If you are connecting here, 5 volts. Like this is happening. Third one is also there, number 3, that is called by the name multi-tapping transformer. Multi-tapping. So the third one is multi-tapping transformer. First one, a normal transformer, only 2 outputs. Only one output, only 2 wires. Central tapping transformer, second one, at the center of at the midpoint of the coil also, means number of turns where the midpoint is present, we are taking one output here now. That is called by the name the central tapping transformer. Multi-tapping transformer means 50 number of turns, one output, 100 number of turns, one output, 200 number of turns, one output, 400, like that we are taking out here. That is called by the name the multi-tapping transformer. In the case of a central tapping transformer, if you are connecting here to here, maybe 5 volts, here to here also 5 volts, here to here it is 10 volts. Therefore, there is a knob is present. In the case of transformer or output, that knob, if you are shifting like this now, 2 volts, 4 volts, we will get. But multi-tapping is not like that. Multi-tapping, there are so many turns are there. Okay, 2 volts if you want to get, 2 volts only, 4 volts, 5 volts, 6 volts, 10 volts, whichever you want, you can get it here. The voltage, output voltage, we can adjust by using this. But here we are going to adjust the output only for the 2 voltages. Here we cannot adjust the voltage. We will get only a constant one output here. These are the different types of transformers under the step-down transformer. High voltage to low voltage we are converting, of course, AC. AC only it will work under transformer. DC will not work under transformer because there is no mutual induction. One more question for your board examination. Transformer, is it works under DC? No. Why it is not works under DC? Because there is no mutual induction. You are going to learn. You are going to learn all these things in the case of your electricity, AC theory. So anyhow, transformer can be divided into step-down transformer, normal transformer, central tapping transformer, multi-tapping. Okay, now I will going to take up this central tapping transformer. I told you already, this is a central tapping transformer. If you are connecting between here to here, maybe you are going to get 5 volts. Here to here also, you will get 5 volts. If you are connecting a voltmeter from this point to this point here, you will get 10 volts. Means, if you are connecting between here to here, it will show as plus 5 volts and this is 0 volts. Here to here, if you are connecting, this is 0 volts and this is minus 5 volts. Because it is an alternating current. Here to here, the difference is equal to 10 volts. Don't have it is 0. Plus 5 volts to minus 5 volts. The difference is equal to 10 volts. Here to here, difference is 5 volts. Here to here, difference is 5 volts. 0 minus 5, 5 volts. 0 plus 5, 5 volts. Plus 5 to minus 5 volts, 10 volts. During the positive half cycle, this is happening. During this positive half cycle, this is happening. During the negative half cycle here, this will becoming minus 5 volts. This is 0. This becoming plus 5 volts. Everything is reversing. This is what is happening during the positive half cycle and during the negative half cycle. During the positive half cycle, this is more positive. This is lesser positive. This is negative. During the negative half cycle, this is negative. This is lesser negative or lesser positive. This is more positive. Again, I will repeat. During the positive half cycle here, this terminal is plus 5 volts. This is 0. 0 and plus 5 volts, if you are comparing here, more positive, less positive. And this terminal is acting as minus 5 volts. More positive, lesser positive here means negative. Positive, this is negative. This is positive, this is negative comparatively. If you are comparing the two students, one student who got 50 marks, another student who got 100 out of 100. Who is a good student? 100 out of 100 who got it. If you are removing this person, the student who got 50% marks, a student who got minus 50% marks means negative marking. If you are comparing these two, he is the good student. So comparatively, compared to this and this here, this is positive, this is negative. Compared to here and here, this is positive, this is negative. During the positive half cycle. During the negative half cycle, reversing. This is negative, this is positive. During the negative half cycle, this is negative, this is positive. Compared to here and here, this is positive, this is negative. Compared to here and here, this is positive, this is negative during the negative half cycle. I will conclude now. During the positive half cycle, between this point to this point, this is positive, this is negative. During the positive half cycle, this is positive, this is negative. During the negative half cycle, this is negative, this is positive. During the negative half cycle, this is positive and this is negative. So don't forget, comparatively with respect to each other. Comparison with respect to each other. Okay, yes. Now I will start with the full wave rectifier. The first concept under full wave rectifier, we had to show the circuit diagram. I told you already, we require a step down transformer to convert the high voltage in the form of low voltage. So for that purpose, I'm writing a transformer here. So this is a transformer that I'm writing. It is a step down transformer. Number of turns here, it is more. Okay. Number of turns here, it is less. This is the iron core transformer. It is containing the iron core. I am writing the iron core. Here the number of turns is less. 3, 4, 500 turns maybe. This is central tapping transformer. Of course, which kind of transformer? Step down transformer. Central tapping, step down transformer. Central tapping means at the midpoint we are connecting a wire and we are taking outside like this. This is central tapping. And now for this particular one, we are going to connect a diode here. We are supposed to connect here, it is 2 diodes. 2 diodes we are going to connect. So here I will going to connect the first diode. This is the diode number 1. I will write D1, diode number 1. This is P and this is N. Here I will going to connect a resistance, or you can take it outside and you can connect, no problem. So here I will connect a load resistance. Yesterday itself I told you about this. It is a load resistance, RL. A large resistance is called by the name the load resistance. Here we are connecting one more diode, diode number 2. Then we are connecting all these things common together like this. For all practical purpose, this is taken as a D2, of course, diode number 2. This point, I will consider for our reference, for our study purpose, I will take this one as M point, this one as N point, I will choose. This point, I will take it as C point. This point, I will consider that one as A point. And this point, I will consider that one as B point. Okay. Output and input diagrams, I will show it. No problem, I will show it here. That carries marks. Okay, this is an input wave. Okay, this is input voltage, V input. Okay, input voltage we are going to have like this. AC. This is input voltage waveform. This is output waveform. This is output voltage. This is output voltage. What is happening here? I suppose to show it. During the positive half cycle, what is happening? During this negative half cycle, what is happening? During this positive half cycle, again, what will happen? Okay. During this negative half cycle, what will happen? We have to show in the input and output waveforms. That carries one mark. If you don't show this waveform, you are losing 1 mark for this itself. Sir, I have forgotten, means out of 5 marks, you will get 4 marks only. Yes, this carries 1 mark, this carries 1 mark. Explanation carries 3 marks. Explanation also I will write and I will show it. Okay, this is the waveform that I supposed to show it here. I have not yet written here. Now coming back to this concept. During the positive half cycle of AC, during this positive half cycle of AC, this is positive, this is negative compared to here and here. Compared to here and here, this is positive, this is negative. I hope you understood the concept. So let us see that. A student who got 100 out of 100, a student who got 50% marks, a student who has not passed out, 0 marks. Compared to this A and C, A is a good student, C is not a good student, compared to this and this. But compared to C and B here, B is not a good student, C is a good student. So good and bad, it is a comparative. Rich and poor is a comparative statement. Rich and poor is a comparative statement, I said. Okay, because compared to some countries, India is a rich country. Compared to some other country, India is a poor country. Compared to some country, India is a well-developed country. Compared to some other country, still we are developing country. Still we are developing. So meaning comparison, rich and poor is a comparative statement. Good and bad is a comparative statement. Compared to one person, he is good, we are going to say. Compared to this person may be good or may be bad, we don't know. So good and bad relative to each other. It is a relative terms. Here also, during the positive half cycle, during this positive half cycle, A is positive, C is negative. Whereas during the positive half cycle only, compared to these two here, C is positive, B is negative. Plus 5 volts, 0 volts, and this is minus 5 volts. Plus 5, 0, minus 5. Plus 5, 0, minus 5 during this positive half cycle. Therefore, during the positive half cycle, what will happen here? Okay, I will show it and I will write it here. Okay, during the positive half cycle of AC. During the positive half cycle of AC input, what will happen? During this positive half cycle, what will happen? That I supposed to explain now. So I told you as an example, whatever I told you, that also I will write. A is equal to plus 5 volts, this point. C is equal to 0 volts. B is equal to minus 5 volts. Okay, this is what is happening practically. If you are choosing 10 volts supply, 10 volts or transformer, if you are supplying, if you are connecting a voltmeter between here to here, 5 volts, it will show. Between B and C, it will going to show 5 volts because the difference is equal to 5 only. If this is a C concept here, reason, then how I will going to explain the concept, how we are going to understand. So here A is positive. Of course, point number 1 I will write. Point number 1, between A and C, one by one I will choose. I will choose between A and C. Which is positive now? A is positive. C is negative. Compared to these two, A is positive, C is negative. A is positive, C is negative. If A is positive, C is negative, then P connected to positive here. A is positive, C is negative. Therefore, P, this is P variety, this is N variety, this is P and this is N. P is connected to positive, N is connected to negative. Therefore, I can say here, D1 is forward biased. If D1 is forward bias here, because P is connected to positive, N is connected to negative. I told you because C is negative, A is positive. Therefore, D1 is forward biased. As D1 is forward bias here, this diode is said to be under forward bias condition. Then current starts to flow. Majority charge carrier starts to flow, means current starts to flow. As a current is flowing here, now current is flowing here, the current is passing like this. The current is passing like this. Hence, here there is a voltage. Current is passing like this. I will show the direction of the current also. Arrow mark, I will show it here. This is the direction of the current. This is the current direction. So current is passing like this. Therefore, across this one, there is a voltage. Across RL, there is a voltage. Forward bias, is there is forward bias, diode is conducting, there is a flow of current. D1 conducts. As a D1 conducts, current flows. As current flows here now, it implies there is across RL, there is a voltage. There is an output voltage. There is an output voltage. Therefore, you are going to get an output voltage here. That output voltage, I suppose to show it in the graph here. There is an output voltage I suppose to show. There is an output voltage I suppose to show it. This is output voltage. This is coming because of which diode? D1 diode. That also I will write. But at the same time, what happened to the D2? What happened to this D2? This one, what is happening here? That we are supposed to analyze. So this is between A and C. Number 2. Number 2. Okay, what is happening here? Number 2, between, which are the other 2 points here? C and B. Between C and B. Between A and C is finished. Between C and B. Between C and B. C and B. Which is positive? C is positive. B is negative comparatively. Compared to these two. Compared to these two is different. Compared to these two is different. Therefore, here C is positive here. B is negative here. Therefore, okay, I told you about this. See here. C is positive. C is positive here. B is negative here. B is negative here. Yes, C is positive. B is negative. Don't have an idea that, sir, is it negative and positive? Both it is. So compared to these two, this is negative. Compared to these two, this is positive. So C is positive, B is negative. And hence P connected to negative, N connected to positive. P connected to negative, N connected to positive. Yes, P connected to negative, N connected to positive. Therefore, this diode is reverse biased. D2 diode is said to be under reverse biased. So therefore, I can say here, okay, D2 is reverse biased. Yes, D2 is reverse biased here. D2 does not conduct. D2 does not conduct. As it is not conducting here, current is equal to 0. Current does not flow. There is no current due to this particular one. Due to this, no current. But already current is there due to D1. Due to D1, current is there. Due to D2, current is not present. So therefore, across RL, due to D2, there is no voltage. Due to D2, there is no voltage. There is no voltage. Due to this. But already there is a voltage. That voltage is coming because of this D1. This voltage is coming because of this D1, but no voltage is coming because D2 does not conduct. Therefore, I can say during the positive half cycle of AC, which is conducting, during the positive half cycle of AC, D1 is conducting, D2 does not conduct. During the negative half cycle of AC, during this negative half cycle of AC, everything is reversing. Everything is reversing. This is negative, this is positive, and this is negative, and this becoming positive. So same idea that we are supposed to write. But during the positive half cycle of AC, D1 conducts, D2 does not conduct. Here, D2 does not conduct. D2 is not conducting here. During this stage, D1 is conducting, but D2 does not conduct. During the negative half cycle, what we are supposed to write? So during the negative half cycle of AC, similarly, we are supposed to write. Okay, another 2 minutes, I will cover this. You can see that. During the negative half cycle of AC, half cycle of AC input, during this negative half cycle, what is happening? So this is during the positive half cycle. Now example, like this only I will write an example. Example, A is minus 5 volts. Everything is reversed. C is 0 volts. B is plus 5 volts. If it is happening, similarly, A and C, what will happen? We had to write. Between C and B, what will happen? We had to write. Similarly. So what is happening here? Okay, first one, number 1. Between A and C. Between A and C. Between A and C, A is negative, C is positive. A is negative, C is positive. Therefore, I can write A is negative and C is positive. Let us go back here. I told you A is negative. A is negative here. A is negative, A negative, P connected to negative here. C is positive. C is positive here. N connected to positive. So if I'm writing the polarity, you should not get confused. Here, A is negative, I said. C is positive. C is positive, I said. So A is negative. A negative means P connected to negative, N connected to positive. P connected to negative, N connected to positive. Because of this one, D1 is said to be under reverse biased. So I will write that concept here. Therefore, D1, diode number 1, D1 is reverse biased. As it is reverse biased, therefore, D1 does not conduct. As D1 does not conduct here, current is equal to 0. As there is no current here now, as there is no current is flowing here, during this negative half cycle, don't get confused. I am talking about during this negative half cycle. Here, there is no current is flowing. Here, there is no voltage. Therefore, current is equal to 0. As the current is equal to 0, I can write here across RL. There is no voltage. There is no voltage. Due to which one? Due to this D1 only. Due to D1. Due to D1, there is no voltage. But what is happening? D2, we had to write. Point number 2. Between A and C is over. Between A and C is over. Now between C and B. Between C and B. What is happening here? Between C and B. So in the case of C and B, previous case, C is positive, B is negative, previous case. But now C is negative, B is positive. C is negative, B is positive. So here, C is negative, B is positive. Compared to this one, this is more positive. This is lesser positive. Therefore, I will write C is negative, B is positive. Yes, it is happening like this now. C is negative here, C is negative. This becomes negative here. B is positive, this becomes positive. C becomes negative, B becomes positive. Now, P connected to positive, N connected to negative. P connected to positive, N connected to negative. Therefore, this D2 is said to be under forward biased. P connected to positive, N connected to negative. Therefore, D2 is said to be under forward bias. Therefore, D2, this implies D2 is forward biased. Yes, it is forward biased here. D2 conducts. Yes, D2 is conducting here. There is a current. There is a current which flows. If a current is flowing here, therefore, across RL, there is a voltage. Due to which one? Due to this D2. Due to D2. Explanation is almost over. Now I will going to write the, what is this? The waveform. This is, I will write, negative half cycle is also converted in the form of positive half cycle. This is due to D2. But D1 does not conduct here. Here D1 conducting, D2 is conducting here. Here D1 conducting, D2 does not conduct. Here D2 is conducting, D1 is not conducting. Here again D1 is conducting, D2 does not conduct. It will happen. Similarly, it will repeat. Here D2 conducts, D1 does not conduct. Here D1 conducts, D2 does not conduct. Here negative half cycle, D1 does not conduct, but D2 is conducting. You are going to get the continuous, the voltage supply you are getting, but it is not a constant voltage supply, but it is a variable voltage supply. This idea we are using for our practical purpose, day-to-day life also we are using, but only thing is another circuit we are connecting here to make it as a constant voltage. Called by the name the filter circuit we had to put, then we will get it. So if you are writing this much, it carries 5 marks. Circuit, it carries 1 mark. Waveform, it carries 1 mark. Then you are supposed to write these concepts. Where it has been kept, okay, here. This is positive half cycle we had to show. During the positive half cycle, what is happening? Once you understood the positive half cycle, what is happening, just in a reverse way, negative half cycle, it is happening.